Hello everyone. So in the last lecture we have discussed about the introduction of statistics, and then we realized that we need to collect the data, right, to analyze it. We need to analyze the data to understand what kind of distribution it follows, because it will not be given, right? So we have to collect the data and then we have to interpret it, we have to analyze it, correct? So there are two type of data. One is ungrouped data, the raw data, and another one is grouped data. What is ungrouped data? Data that is listed individually without any grouping or intervals. So it is individually given. That is called the ungrouped data. What are the key characteristics it has? Each data point is distinct and explicitly mentioned, suitable for small database, because it is like all data are given, right? This kind of thing we'll discuss only for the small database. Now one example is the exact ages of 10 students in a class. So because the data is small, that only 10 students, so we can give the exact data, okay, that ages are 18, 19, 20, 18, 21, like that, the exact value, right? So this is an example of ungrouped data. Whereas group data is what? So this is the data that is organized into interval or classes and presented in a frequency distribution table, right? So it is the some interval will have, and then how many data fitted into that interval. That is called the frequency, right? So the data that is organized into intervals or classes and presented in a frequency distribution table. We'll discuss the example. Now the key characteristic of this group data is this is used for large database, large data set where listing individual values is impractical. Right, like now you previous example you collect the ages of 10 students. Now you imagine if you want to collect the ages of the whole state students, the whole state, maybe the first year, second year BTech students. So it's a huge number of data, right? In that case, we will not write the whole data, the exact data, but you will make it as a group data, right? So data is grouped into ranges. Now the example is, look at that. That height of students grouped into interval. So between the height 150 to 160 centimeter, there are 5 students are there. So the height may be 151, 152.3, 159, like that. But instead of writing it explicitly, we write the range, the class, that from this interval 15 to 150 to 160, there are 5 students are there whose height is falling to that category, right? So this 5 is the frequency, correct? So the number of people. Similarly, between the range 160 to 170, there are 12. Between 170 to 180, there are 8 students are there. So this is an example of a group data, right? And then what are the key difference between this two? The difference between two that. So group data is individual values, ungrouped data is individual values, whereas group data is class intervals. Ungrouped data used for small database. Group data is for large database. Ungrouped data is the exact value, whereas group data is the approximate value. Right? It is within the range you are calculating. It is not the exact value you are giving. Then ungrouped data you have direct calculation, whereas group data you required midpoints for mean, median, etc. Right? So why you need the group data? Simplify the large database, because you have a very large database. Here we have given 100 plus or 1000 plus. It may have been 1 lakh plus also. So in that case, instead of explicitly writing the data, we use the group data. And then enable visualization like histogram or frequency polygons. We need the group data, right? Histogram is to represent the data. So in one picture, you will understand that what kind of data you have. right? Then calculate statistics like mean, median for summarized data. For all this, we need the group data. Now, you may have the ungrouped data and then you have to group it. So there is a way to do that. How to convert ungrouped data, the raw data, into a group data. So we'll follow this following step. First is determine the range. Range is the how to find the range, maximum value minus the minimum value. Next is decide the number of classes or number of intervals. So there is a standard rule like Sturge's formula. It says that k equal to number of classes or number of intervals. It is 1 plus 3.322 log 10 log n base 10, where n is the number of data point. So we have to round it up. So with this formula, you can get the number of classes. The next is calculate the class width. So once you have the number of classes, you can easily calculate what will be the length of each of the interval. So it is given by h equal to range, the total range divided by k, and we may round it up if needed. And define the next is define the class interval. So with the help of this width and number of classes, we can define the class interval. Start from the minimum value and create non-overlapping interval of width h. Then finally, tally the frequencies, count how many data points fall into each class interval. Right? So this is kind of standard way to do that, the group data. And sometime you can also group the data depending on your convenience. Right? So now what we'll do, look at this example. The exact ages of 10 students in a class are given below. Convert this ungrouped data to a group data. Now we know the rule. What we'll do, first we'll write them in ascending order, right? So the data in ascending order, given data in ascending order. The solution is, maybe I'm writing as AO, like that means it is the data in ascending order. If you do it, it will be 18, 18, 18, then 19, 19, 2 times 19 is there, then 20, 20 is appearing 3 times, then 21, and then 22. So how many data points we have? There are 10 number of data points, right? So then your first job is to get the range. First is to get the range. How to find the range? Maximum value minus the minimum value. Next, we can calculate the number of class using this formula, then the class width, and then the intervals. Okay, so the first is, what is the range of it? The range of this data point is equal to, the maximum value is what? 22 minus the minimum value is 18. Therefore, the range is equal to 4. Then we have to find the number of classes by using the Sturge's formula, right? So the number of classes is what? Number of classes. So we'll use the formula k equal to 1 plus 3.322 log number of number of data point is 10 base 10. So this log will give you 1. So this value is 4.322. And if you round it up, we may make it as a 5. Right? This value is 5 after rounding up. Okay, just a second. Yeah. So this value is, so the estimated value is 5, number of classes. We could have taken 4 also. Okay. Next is the class width. So once you decide the number of classes, then we can find that what should be the length of each of the interval, right? So the class width is, what will be the class width? It is h equal to the range divided by number of class. So range is 4, sorry. Range is 4 divided by 5. which is 0.8. Now again we can approximate this or round it up to 1. So class width is 1. And then we have the number of classes or number of interval, and each of the interval will have width 1. Therefore we can create the non-overlapping interval. So the class intervals are what? Intervals. So we'll start from the lowest one. So 18, then 19, and then we may make it an open interval, 18 to 19, so that it will be non-overlapping, right? Then 19 to 20, then 20 to 21, and then 21 to 22. And the last one, now 4 have been done. Last one is 22 to 23. So we cleared the non-overlapping class interval. And finally, the frequency distribution table we can calculate, we can create. So we'll have to make a table like this. And then this is the class interval. And this side it will have the frequency. The frequency. And this side it is the class interval. So we had the ungrouped data. We are making it to the group data. So how? Now we have 5. So we'll make 5 boxes. One like this. So the class interval is between 18 to 19. So how many elements are there between 18 to 19? There are 3, right? There are 3. So the frequency will be 3. Then between 19 to 20, in the next interval, there are 2. So this is 2. Then between 20 to 21, there are 3 again, right? So this is 3. Between 21 to 22, 21 to 22 is only 1. So this is 1. And 22 to 23, there are 1. So this is 1. Right? So we converted this ungrouped data into a group data. And in reality, in practice, to do that, we need to get many other information from this frequency distribution table. So we can extend this table and we can create the midpoint, right? Midpoint of this interval, and then you may also have the cumulative frequencies also, because later on we'll see that we need from the group data to analyze the things, we need to have these parameters also, right? The cumulative frequency. So what is the cumulative frequency? It is 3. Next is 3 plus 2, 5. Next is 5 plus 3, it is 8. Next is 8 plus 1, it is 9. And next is 10. Like that, you can calculate the cumulative frequency. Midpoint is the midpoint of that interval, which is 18.5, 19.5. Like that, you can create the each of the intervals midpoint. Right? Why I am extended this table? Because sometime we need this information. Later on, we'll see. Right? I hope you understand how to ungroup the data, how to group the data from an ungrouped data. Okay. So this is the one, as we have already done. The whole table is given in a very formal manner. Okay. So the descriptive statistics, we talked about the descriptive statistics, right, in the last lecture. And we mostly will discuss the 3 fundamental aspect of this data, descriptive statistics. What are the things? One is measures of central tendency. So mostly the key measurements are mean, median, and mode. Then the variation, that the key measurements are range, variance, standard deviation, and quartiles. And then the same, the pattern of the distribution of values from the lowest to the highest value. So the key measurements we'll do here, the skewness, right, and kurtosis, etc. and etc. We'll discuss one by one. So first we'll discuss the central tendency of ungrouped data, right? Central tendency of ungrouped data. So mostly all of us know about the mean or average. So we have some data in ascending order x1, x2, xn, right? So these are the, I have n number of ungrouped data which are in ascending order x1, x2, xn. Then what is the mean of it? It is the sum of all of them divided by number of elements. So it is summation of xi divided by n. The median is what all of us know. So if the number of element is odd, then the median is the central value. It is the x of n plus 1 by 2th element, and if n is even, it is the x of n by 2 plus x of the like n by 2th element and n plus 1 divided by 2th element, right? N by 2 plus 1th element, then it will be the median. And mode is what? The mode value is appears the uh, the values that appears most frequently. That means whose frequency is more, that is the mode, right? So mean, median, and mode are the key element of the measures of central tendency. So for the case of ungrouped data, these are the formula to find the mean, median, and mode. Note that it is for the ungrouped data. Now then, if you have an example, the same example if you take, then what is the mean, median, and mode for this? So what we have to do first, let us make the data in ascending order, right? Data in ascending order. It is 18, 18, 18, the same thing that we have done in the last example. And 19, 19, and 20 is also appears 3 times, 20, 20, then 21, 1, and 20. So there are 10 elements. So what is the mean of it? Mean is the sum of all of them divided by number of elements. So summation of xi divided by n. So what is the, if I add it all of the numbers, you will see it is 195. And there are 10 number of data, so this is 195 by 10, so therefore the average or mean is 19.5, right? Now therefore this is the mean. What is the median? So median is like you have to do that, because the number of data is even, so we have to use the that x of n by 2th element plus x of n by 2 plus 1th element, right? So the n by 2th element means 5th and 6th element divided by 2. What is the 5th element? 5th element is this one, 6th element is this one. Therefore the median is equal to the 5th plus 6th element divided by 2. So which is 19 plus 20 divided by 2, which is again 19.5. So in this case mean and median are same. Now next is mode. What is the mode? Mode is the element which appears most frequently, right? So what is appearing more frequently? This 18 is appearing 3 times and 20 is also appearing 3 times, right? So the mode is actually 2 here, right? There are 2 mode of it. So the mode is 18 and 20. So this is a bimodal case. I hope it is clear, very easy. All of us know. So I don't want to spend more time into it. So this is the formal answer. Then I'm giving another example. Just look at this data and then find the mean, median, and mode of this following data. So that you may take it as homework. I may also show you the answer. Like here, if you do the data in the first job is to make them in ascending order. So you do it in ascending order like this, right? And then mean is, we observe that there are 39 number of data, so it is an odd number, and mean is equal to the sum divided by 39. So you'll see this is the mean. The middle value, that is the median. Now it is the odd number, right? So it is x of n plus 1 by 2th element. That means it is 39 plus 1 divided by 2. So 20th value we have to calculate. The 20th value is actually 85. Therefore this is the median is 85. And mode is, again you see that 69 is appearing 3 times, most frequent thing is that 89 is also appearing 3 times and 92 is also appearing 3 times. In this case, it mode is three numbers: 69, 88, and 92. I hope it is clear. So easy. So next we'll discuss that how to represent the data in visualization, right? So first thing we'll discuss here we'll discuss only few things about it. First thing we'll discuss about the histogram. What is a histogram? A histogram is a graphical representation of the distribution of numerical data using vertical bars or display the frequency of data points within consecutive non-overlapping interval. These intervals are called beans or classes. Right? We will see the example. So basically, it is a graphical representation of some data, right? Numerical data. Now, what is the key characteristic of it? So the x-axis represent the beans or the class interval. Y-axis shows the frequencies, and these bars are adjacent, and the areas of the bars represent the proportion of data in each class. And when we can use this histogram, so to visualize the distribution shape, whether it is normal or it is skewed or it is binodal, we can use this one to see that identifying central tendencies and spread, how it is spreaded, where the central tendencies are there, where from the picture, from the this representation, we can also identify what will be the mean, median, mode, right? Then that whether there is any outliers or gaps in the data, like some values are very extreme, maybe the data, that kind of things also we can identify from the histogram. And it is useful in descriptive statistics and data analysis, right? It is useful in data analysis. Now look at the same examples, the exact ages of 10 students in a class. So the histogram of this ages of the student, if you do it, so we'll have this x-axis represent the beans, right? And then the y-axis represent the frequencies, that how many elements you have, and these are the this beans or the class interval, right? So 18, you have appeared at the ages 18 appears this within this interval, you have 3, so therefore this size is it is that up to it goes up to 3, and this is from there to there. Like that the histogram is defined. We have one more example. Look at this example. It is a little bit big data. So monthly salaries in dollar of 50 employees in a company is given like that. Then the frequency distribution, if you collect, so from the ungrouped data, you make it as a group data, and then you have seen the frequency distribution table is this. So between the range 33,000 to 3,500, the frequency is 1, 3,500 to 4,000, frequency is 5, like that it is given. So we have a frequency distribution table, then we can certainly make the histogram of it. How to do? So we just write these intervals, the class intervals or beans, right, in the x-axis, and then the y-axis represent the frequencies. And we have seen that this one has the maximum frequencies having this 4,500 to 5,000. So we have seen that it is the 14 is that one, right? And we can see that it is very much kind of a normal distribution from the data, right? So from this picture we understand that it is kind of normal distribution, correct? Now see the that means this data, from this data we first did the histogram, and then we try to analyze it, which kind of distribution it follows, the salaries. And by looking at the picture we understand that okay, it is somehow following the normal kind of things, right? The bell shaped curve, we all know, right? It is kind of bell shaped curve. So these are the use of these histograms. There is another way to represent the data. It is the dot plot. So a dot plot or dot chart is used to display the frequency of individual data points along a single number line. The key features are it works best for small and discrete data set, right? So if you have a discrete type data set and the small number of data points you have, then we mostly use the dot plot. It is another way of representing data, and each dot represent one occurrence of a value. So whatever, if you have two times occurrence of a value is occurring two times, so you'll have two dots. Like that it is made. And dots are stacked vertically for repeated values. So we'll see in this the same example if we take, then the dot plot of is it's like 18 is appearing three times, so then we'll have three dots here. 19 is appearing two times, so there will be two dots and vertically they are given. Right? Similarly, 20 was appearing three times, so there are three dots given in vertical order, stacked vertically. 21 appears one, 22 appears two. So in this way, you can also represent the this data using the dot plots, right? So let me end the lecture up to that. In the next video, we'll discuss about the group data and its mean, median, mode, all these things, right? I hope you enjoyed the video. We'll meet in the next video. And the content I have taken from this books, some other internet access also I have taken, right? Thank you very much. We'll meet in the next video.